Following on our set of tools, I'm going to show you a way in which you can access the presets as tables if you want to see the values in such manner. If you go to your tools, you can now click on the preset grabber. When you do that, a new node appears outside of the TDMorph system. And you guessed it, its input is a preset manager. So what does this object do? Basically, it takes a target preset manager, it queries what are their presets, and then it gives you a set of outputs that correspond to the number of presets you have in there. So let's see what happens, for example, if I create a new preset. Pay attention to these outputs in here. I'm going to create a random preset number 5. So now I have an extra output that was just created for me. So if you inspect this, you will notice that these are just tables. And each one of these tables, they contain all the information for each one of those presets. So this is the preset I am in at the moment. And you can see the data here. And the first preset was or had these values here. And you don't only have the values, but you have more information. For example, the ranges, you have the minimum and maximum, you have the time, the distribution, and the log status. And this is all the time automatically updated. So if I override my first preset, this will change accordingly. So you don't need to do anything in particular to it. It will always be up to date. So let's explore a little bit what is inside of it. As you can see, it's just a collection of tables. Each one of them gets created when you alter something in your preset manager, in your core preset manager, and then there's a bunch of Python code that handles the transformation. So this can be useful for those of you, like I said, who are comfortable dealing more with tables in creating your own applications. Yet another thing that you may want to do is to have a way to access these parameters as data that you can use to change something. In order to do that, you can go to Tools, click on the morphing channels, and then you will get a base. So for once, this base though doesn't refer to any preset manager, and that is because the data we're looking for has nothing to do with presets. It has to do just with the parameters. So if we take the output of here and we see what it's doing, then we see that is the chop or the channel values for each one of these parameters. There could be a situation where you have more than one container. So let's say another one here. I'm going to put some parameters in there. For example, the offset and the harmonics. And now you will notice that they do not appear in here. Also, if I put something else in this previous one. And that is because for efficiency purposes, this is not deeply dependable. So that means it is not updating automatically. I need to recreate this so that it shows me all the available channels. It's just something you need to know if you're dealing with this. And now I have a property name also per container. So I have my period 1 container and my offset in container 2. And they all respond whenever you change something here. So you can write a script, for example, based on changes on this data. Now, you may be missing as well something to interact with the changes of this container. So I'm referring to these transformations, morphings, and preset settings. So for that purpose, there is the morphing timers, which is a base very similar to what we just saw. But instead of outputting the parameters, it gives you the clocks. So if I move something in here, for example, if I go to some preset, you can see the clock changing and giving me some useful signals like the ready and the done pulses, as well as the timer fraction. So this allows you to interact with the transformation data. And like before, it corresponds to as many containers as you have. Something to know about this is that it only responds to global transformations. So anything that is global will be represented here, but not these, for example, which are local transformations, because they have their own inner clocks. All right, I hope this gives you enough ideas to keep exploring.